Hi everyone, this is the shell of a black abalone, an endangered species of marine snail. This is a typical habitat for black abalone adults, which has complex surfaces and deep crevices that provide algae and shelter. Black abalone are only found in rocky intertidal and shallow subtidal reefs in California and Baja California, Mexico. Today, populations in California remain low densities, and population status in Mexico is largely unknown. Black abalone is both important ecologically and culturally because their grazing maintains California's coastal ecosystem and they serve as a food source for sea otters. Coastal tribes have harvested black abalone for millennia for its meat, and its shells were used for money and to make fish hooks and ornamental items like the one I have here. More recently, black abalone was an important component of commercial and recreational fisheries. The primary threat to black abalone is a disease known as the withering syndrome, which causes their foot to shrink, preventing grazing and leading to starvation. Various government agencies have been conducting population monitoring surveys, and experts have documented over 99% population declines. So we need to find ways to build black abalone populations back up. One of the ways we can do that is through translocations, which means collecting and moving abalone from one site to another. This leads to my research question: what are the best practices and methods for black abalone translocation and characterization of juvenile recruitment habitat? To do translocations, we need more information. So we need to tag and track abalone and see how well they survive. In order to answer my research question, I worked with NOAA Fisheries to produce 2 white papers totaling 76 pages that synthesize expert opinion and literature into actionable recommendations. I conducted an expert elicitation interviewing 13 black abalone experts and a literature review. The findings were then synthesized in a spreadsheet and the themes became my recommendations. Overall, there were 3 overarching recommendations. The first recommendation is understanding how black abalone habitat contributes to translocation success. These animals really don't move much, but translocating them can definitely cause stress on them. So we need to consider how the substrate used for translocation and how the substrate allows for monitoring and supporting the life functions of black abalone. The second recommendation is clarifying experimental methodologies. Tagging translocated black abalone is challenging because their number tags tend to fall off over time by the constant rubbing on their shells with the substrate. This is why researchers are trialing pit tags used on other abalone species, which implant into the shell, which last longer and have a unique number tag that can be read with an electronic reader, even when abalone are in deep cracks. But pit tags take a long time to implant and cannot always be read. The third recommendation is developing a deeper understanding of the biotic and abiotic needs of juvenile abalone. Juveniles are so small, so focused surveys can help to identify juvenile habitats that are undersurveyed currently. Researchers are also experimenting with juvenile recruitment modules that can be taken apart easily to monitor recruitment, count all the organisms in it, and put the module back together. As a whole, endangered species conservation management often involves making high-level decisions when evidence is absent. So cross-border collaboration becomes essential to enhance the overall success of saving the endangered species throughout its entire range. My research method systematically collected expert opinion and literature and Black Abalone Recovery Team Meeting is a good framework for this collaborative framework. My research showed an important lesson about coordinated efforts, and this can be applied to other endangered species conservation. I would like to thank my site supervisor, Susan Wang, my faculty advisor, Lawrence Waters, all of the Black abalone experts, and my Capstone cohort and friends and family for supporting me throughout this project. Thank you. Yeah, so Black abalone's habitat use actually varies according to the presence of sea otters. So sea otters were hunted to extinction in around the 15th, 16th century, I want to say, but they've been slowly introduced back to California. So they exist in some places in California and not in others. In the two locations where Black abalone are abundant in Southern California, in San Nicolas Island, the black abalone are often observed in crevice habitat, which is a behavior that we expect with the presence of sea otters. But with Santa Cruz Island, there are no sea otters there. So black abalone are actually often seen roaming around in the open, just on the seabed. But there was a legislation change in 2016 that allowed sea otters to continue to expand to their natural habitat range. So as they colonize other California Channel Islands and maybe the Maine coast, we are expecting to see black abalone's distribution to change, and they will also use more crevice habitat, especially in places like Santa Cruz Island where they have not been.
Does anyone know if, how many of the albums?
Yeah, so the question was how many abalone are there in the wild? NOAA Fisheries actually doesn't have a very accurate, a good estimate of abundance estimate because for the long-term monitoring surveys that I was just talking about, they've been conducting them since 1980s, and they're focused on looking trends over time. So they have about 40 years of data, but for the locations of the long-term monitoring surveys, they've picked locations with high abundance of abalone. So in that way, they're not very good at estimating abundance. And the reason why I say there's been a 99% decline in population is because experts have been going to these places and observing abalone, and they often see thousands of abalone in the 1970s before the mass mortality events. But then after that, in a few short years, they returned to the same sites and they were only finding one or two instead of thousands. So, yeah.